Hello students and welcome to my channel Maths Hub. So today in this video, I'll tell you how to solve problems on system of equations with no solution. So I will recommend you to just check my previous video where I have explained the conditions of the system of equations. So we have divided the system of equations into two types, that is a non-homogeneous system of equation and a homogeneous system of equation, right? So all the conditions for the existence of solution depends upon the rank. So let us try to understand that when will a system of equation won't have a solution. So we need to discuss the consistency of the system of equation. So the first step in this is to convert any system of equations into the form AX equal to D. So you can see that the coefficient matrix here is 2. The first row is 2, 3, minus 4. The second row is 1, minus 1, 3. The third row is 3, 2, minus 1. And then we have the system of unknowns here as x, y, z, and we can write the right hand side matrices minus 2, 4, and minus 5. So you might have seen that for consistency, you have to find the rank of A augmented D. Only then you will be able to decide whether it has consistency or it has inconsistency, right? So how to calculate the rank of A augmented D? So let us try to write the augmented matrix. So we will first write the coefficient matrix, that is 2, 3, minus 4, 1, minus 1, 3, then 3, 2, minus 1, and we will put a dash symbol, or we can put a dotted line over here, and we can write the coefficient matrix as minus 2, 4, and minus 5, right? So now after this, we will try to convert this into a echelon form, row echelon form, and we will try to compute the rank of this whole matrix, right? So we have converted this into a matrix form and then into a augmented matrix. And now we have applied the row transformations. R2 is equal to R2 minus half R1 and R3 is equal to R3 minus 3 by 2 R1. So when we apply, we get the transformations like this. So now by this time you should be in a situation to convert the matrix, right? And then finally we can subtract these two rows. R3 is R3 minus R2, and we finally get 0, 0, 0, minus 7 as the bottom row. So at this stage you can see that this matrix has been converted into a row echelon form. So if I check the rank of A augmented D, you will see that for the entire matrix, there are 3 non-zero rows. So the rank of A augmented B is 3. Now I need to compare the rank of A augmented B with rank of A. So how to calculate the rank of A? To calculate the rank of A, you can hide the coefficient matrix. When you hide the coefficient matrix, you get the first 3 rows and the first 3 columns, right? So in the 3 rows, you can see that the third row is completely 0. That means there are only 2 non-zero rows. So we get the rank of A as 2. So from here, you can see that the condition that gets satisfied is rank of A augmented D is not equal to rank of A. And whenever rank of A augmented D is not equal to rank of A, we get that it is inconsistent, right? So it's simple enough. So let's try to move to another problem and see how to do it. So we have to find out for what values of K the set of equations has no solution, right? So this is where we have K. So let us see how to solve the system of equations, right? So first step is we try to convert this matrix into augmented matrix, that is A augmented B. So A matrix is, so we have 4 variables here, X, Y, Z, and T. So the first column is for X, the second column is for Y, the third column is for Z, and the fourth column is for T. So when we write the coefficient matrix, we get 2 minus 3, 6 minus 5. Then we have in the second equation, there is no x. So we have 0, then 1 minus 4, 1. And in the third equation, we get the coefficients 4, minus 5, 8, and minus 9. Then we can put a dash over here or a dotted line, anything. And on the right hand side, we have the entries 3, 1, and k. So again, we try to convert this into a row echelon form. So we have applied the transformation. R3 is R3 minus 2R1. So when we apply this, we get the last row as 0, 1 minus 4, 1, K minus 6. Then we can see that these entries are same. So we can again apply R3 is R3 minus R2. So we get 0, 0, 0, 0, and then K minus 7. Now, for this equation to have a inconsistent solution or a no solution, what is the criteria? The criteria says that rank of A augmented B should not be equal to rank of A, right? Now in this stage, can you tell me what is rank of A? You can put your hand on the coefficient matrix, right? So you can see that one row is completely zero, so rank of A is 2, right? Now for rank of A augmented B to not be equal to 2, that means this entry cannot be 0. If this entry becomes 0, then the rank of A augmented B will become 3. So that means K minus 7 cannot be equal to 0. If K minus 7 is not equal to 0, that means what is K? K is not equal to 7. So for what values of K will this system have a no solution? The answer is K is not equal to 7. Right? For k not equal to 7, the system of equations will have a inconsistent solution, right? Similarly, you can solve this problem. You have to show that the system of equations are not consistent. So I've given you the answer, but without looking into the answer, you can check it on your own. You can see that you have converted this into an A augmented B matrix, and after applying the transformations, it gets reduced to this matrix. So at this stage, you can see that the rank of A augmented B is 3, while the rank of A augmented A is 2. So both the ranks are unequal and the system of equations are inconsistent, right? So I hope you have understood the questions, right? And do try these problems. I've given you the answers also. So if you have any doubts, put it in the comment section. If you like the video, do hit the like button. And those of you who have not subscribed my channel, do subscribe my channel to get the latest updated videos. And do share the videos to the ones who need them. Believe in yourself and you will be able to succeed. Thank you so much.